To trace such programs, you need to grab a pen and paper to draw the objects when they are created as we progress in the tracing steps. Any object created during the tracing steps, it will be represented by a box, and inside the box we write the current values of its data members. And as we progress in the tracing steps, whenever a data member of any object is changed, then we have to change it inside its box. In the beginning, take a minute and have a look into the class definition and try to identify its data members and its methods. Try to identify whether there are static members or not, whether the class has multiple constructors, it has overloaded methods, getters and setters for some data members, whether it has a method that is responsible for printing some of the data members, and so on. This will help a lot to trace your program quickly. In our example, the class name is testClass and it has two data members. The first one is an instance variable which is non-static, that is integer and called x, and the second is a static variable which is integer that is called y and it is initialized to 10. Also, it has multiple constructors. The first constructor is the default constructor and the second constructor has an integer input parameter. The default constructor initializes the instance variable to 200 and increments the static variable by 1. Also, it has a print method that is responsible for printing the value of x and y separated by dash, and this method is called output. Also, it has a method that is overloaded method. It is called add. The first definition, which is its signature, has an input parameter, single input parameter as an integer, and the second definition as a signature, it does not have any input parameter. The first method adds the input parameter value to the current value of the instance variable x, and the second method adds the current value of the static variable y to the current value of the instance variable x. Let us start the trace. Before you begin the tracing, any static variable you have in any class, first draw a box for it, label it by the name of this static variable, and put its initial value. Since we have a static variable y inside the class testClass, so we have a box for this variable. It is called y and the label inside that its current value is equal to 10. Next, you start the first line, and this is where we are now in the main program. Here we are creating an object of testClass that is called A. It is calling the default constructor. So where is the default constructor? The default constructor is here inside the class. What does it do? It initializes the instance variable x to 200 and increases the current value of the static variable by 1, which makes it equal to 10. So when we go to the next step, an object will be created called A. The instance variable x inside it is equal to 200, and at the same time it will increase the shared variable y by 1. And this is the picture that we are going to have. So you draw a box, you label it by the object name, which is A. You put all instance variables inside with their current values. And since we have x is equal to 200, so we label the variable x as 200. And since y is shared, we draw an arrow from the box of the object to the box for the static variable. And notice that the current value of the static variable has changed from 10 to 11. Why? Because we increased it inside the default constructor. After going to the next line, in the next line also we are creating another object that is called B, but the compiler is not calling the default constructor. It is calling the constructor that has one input parameter. And where is this constructor? Here is the definition for the constructor. Inside the constructor, it checks the input parameter in UX. If it is less than 0, then it will initialize the instance variable x equal to 200. Otherwise, it will save the input parameter into the instance variable x and initialize this x by the input parameter. Now, since the input parameter is 40 and it is not less than 0, so this constructor will initialize x to 40. In this case, you draw a box for the object b, you label the box b, and you put the value of the instance variable inside it, and it's equal to 40 because the constructor initialized it to 40. Notice that inside this constructor, the value of y has not been changed, so therefore the current value of y is still equal to 11. Then you draw an arrow from the object to the static variable because the static variable is shared and it can be controlled by the object b. We are now in line 3, and in line 3 we are also creating a third object that is called c, and also we are calling the constructor that has a single input parameter. This constructor receives minus 100 as input parameter and compares it against 0. Since it is less than 0, then it will initialize the instance variable x to 200. And after that, we draw a box for the object c, and you put the instance variable inside it, and since the value of x is equal to 200, and then you write 200. Since the variable y is shared also by this object, so you draw an arrow to the static variable telling you that this object can change the value of y. When we reach this line, 3 objects have been created, and this is the picture of the current state for each object. For object A, the value of its instance variable x is equal to 200. For object B, its instance variable x equal to 40. And for object C, its instance variable x is equal to 200. Now we are calling the method output for object A, and this is the state for object A. So where is this method? This method is here. Simply it prints the current value of x followed by dash followed by the current value of y. By looking at the state of the object on the picture, the value of x is 200 and the value of y, which is the shared variable, is equal to 11. So when we proceed to the next line, on the screen it will be printed the value of x followed by dash followed by 11, which is the current value of 100. Now by going to the next step, we are referring to object B, and this is the state of object B, and we are calling the method output, and again it prints the value of x followed by dash followed by y. So the output printed on the screen will be 40-11. By going to the next line, we are calling the method output for object C, and this is the state of object C. So it is going to print 200 followed by dash followed by the current value of y. Let us continue. Now we go to the next step. Now in the next step, we are calling setX method for object A, and this is object A. So where is the method setX inside the class? This is the method setX. It receives an input parameter which is equal to 30. Since it is not less than 0, so it will save the input parameter into x. The current value of x is 200, so this method will replace 200 by 30, and you can just simply draw over 200 and you write 30. So erase 200 when you have the drawing on your paper. Just erase 200, cross it out, and write 30 on it. And this is what we have done on the picture of the object A. In the next step, we are calling the static method setY, and we are providing the input parameter 200. Notice that we are calling the method by the class name. So where is setY by the class name? It is here. See that setY is a static method. So it will take 200 and will replace it to y. So that means the value of the static variable 11, it will change to 200. And this is what you're supposed to do on the drawing. You remove 11 and you replace the value of y by 200. In the next step, we are referring to the add method for object B. This method is overloaded. So which method the compiler will select? It will select the method that has one input parameter, which is right here. So the value 5 will be saved into the input parameter value, and it will be added to the current value of x. Since we are referring to B, this is the current state for B. So the value of x is 40. So 40 plus 5 will be 45. So the value of x for object B will be updated to 45. So remove 40 and replace it by 45, and this is what we have done here. In this line, we are calling the overloaded add method, but for object C. And this is the current state for object C. Where is this method? This is the method right here. What does it do? It adds the current value of the static variable y to the current value of x. The current value of x is 200 and the value of y is 200. So this method will add 200 of the value of y to 200 of the value of x and replace it into x. So the answer will be 400, and this 400 will update the value of x. So cross out 200 and replace it by 400. Now the last three steps are simply for printing, and we already got familiar on what the output method does. So it will print the value of x of a followed by dash followed by the value of y. So the output will be on the screen 30-200. Similarly for B, it will print 45-200, and for C, it will print 400-200. So this is how you trace your program. Whenever in any step an object is created, simply represent it by a box and put the current values for all of its instance variables inside this box. And whenever you call a method of any object, just go to the box and see what is the current values of its data members and see what this method is doing on these data members.